Welcome to the VisualCAM Quick Start tutorial series, brought to you by Microsoft. Today we'll be demonstrating rectangular nesting. Before we begin, let's talk a bit about the VisualCAD display. When you run VisualCAD for the very first time, your screen may look like this. These windows on the left belong to plugin modules that are currently loaded. For now, let's close all of them. Now, let's begin by launching the VisualCAM-NEST module. From the Plugins pane of VisualCAD's home ribbon bar, you will see the VisualCAM main menu. Drop down the menu and pick Nest to load the nesting module. Docked on the left, you will see the nesting browser. Notice that it is organized into tabs, representing each step in the nesting process. You can resize the width of the browser, making sure that all of the command icons and menus are easily accessible. Now, let's load the part file containing the geometry for nesting. From the VisualCAD main menu, select Open. Locate the VisualCAM Quick Start folder shown here. Then, select the VisualCAD part file named Rectangular Nest Quick Start Tutorial and then pick Open. The following basic steps are included in the nesting process. First, we load the VisualCAM-NEST module and define the nesting type to be performed. Then, we open the VisualCAD drawing where the stock material and production parts are staged. Then, we select the sheets to nest our parts in, and then select the parts to nest. We choose our desired nesting parameters. Then, we preview the nest, making any final adjustments. Finally, we commit the nest, creating the actual nested sheet geometry. Let's take a look at what we've done in VisualCAD to prepare for nesting. You can refer to this as the staging process. We have brought together and located on the screen the geometry that we want in the nesting process. As you can see, we have one or more shapes that represent the stock or the remnant material. We also have one or more shapes that represent the production parts that we want to nest within the stock material. Here are two tips to consider when staging your parts. First, when you stage your parts, stage them around the outside of the stock material, not within the stock material. The nesting software will place the parts in the stock for you. Secondly, do not place parts inside the cutouts of larger parts, as this may confuse the nesting software into thinking that it is a detail of the larger part. Keep all of your parts separated. Now, from the nesting browser, choose the Select Type of Nesting tab. In this guide, we will be demonstrating rectangular nesting, so we will select that option. You will notice a Help button located on each tab of the nesting browser. Selecting it will display documentation for each option on the active tab. From the Select Sheets tab, pick Select Curves. Now, we select the shapes that represent the stock material and then right-click or press Enter to end the selection. Notice that an entry is made into the table. A default name is generated as well as the count, and we'll get back to the grain direction in just a little bit. Let's change the count to 2. This means that there are 2 identical sheets used to nest the parts. You can select additional shapes for stock, but all of them must be rectangular. Next, we'll select our parts to be nested. Pick the Select Parts tab of the nesting browser, and then pick Select Curves. Then, we'll window select all of our part geometry and then right-click or press Enter to add each part to the parts list of the nesting browser. The nesting software determines the exterior and interior of each selected part. As we can see in the parts list, each exterior closed curve is defined as one part. Any interior closed curves are defined as holes within each part. If we select a part from the parts list, we see that it is highlighted in the graphics window. If a part has multiple interior cutouts, each is listed in the parts list under its associated part. Now, we'll enter the count for each of the parts that are needed in the nest. For this tutorial, you can use these amounts or adjust them to see different nesting results. For part 1, the count will be 32. For part 2, it'll be 4. For part 3, we'll use 50. Part 4, we'll use 4. Parts 5 will be 6. And part 6 will have a total count of 16. Now, we'll select the Choose Nesting Parameters tab of the nesting browser to set 2 other parameters. The first one sets the distance between adjacent parts. Here, we'll enter 0.15. The second is the distance between the outermost parts and the outer edge of the stock material. For this, we'll enter 0.25. There are also options to automatically tag each nested part, and layout options for arranging your nested sheets. Now, we'll select Execute Nest, and then Preview Nest as well, and notice that 2 sheets will be used. The last thing we want to do is to impose a grain direction control on this larger part to force it to be vertical. In order to do that, I need to specify the grain direction on the stock material as well as that part. First, we'll go back to the Select Sheets tab and set the grain direction to a long X. Then, on the Select Parts tab, I will set the grain direction on this larger part to be a long Y. Now, we'll select the Choose Nesting Parameters tab. We'll execute the nest and then preview the nest, and we'll see that that part is now aligned vertically. Each time the nest is generated, the system will calculate an efficiency factor, referred to as % utilization of the stock material. Once we're satisfied with the layout of the nest, we will select the Commit Nest button. This writes the geometry of the individual sheets onto individual layers in your current CAD part file. The geometry can then be used for machining or any other application you wish. This completes the Quick Start tutorial for rectangular nesting. For further assistance, you can visit the online help supplied with the program or visit www.mexsoft.com for additional tutorials. Thank you.